right, I'm going to have you go on YouTube and watch the following video. And then you're going to have to explain what this video shows. So pause this Edpuzzle video and go to the following YouTube video to tell me what this video shows. And write it down in this area. All right, so volume of pyramids. You should have learned in that video, that YouTube video, that it takes it takes 1/3 of a prism to fill up a pyramid. So the volume formula for a prism was the area of the base times the height. So the volume formula for a pyramid is 1/3 the area of the base times the height, where h is the height of your prism, your pyramid. We're doing pyramids right now. And b is the area of your base. Now a cone is kind of like a pyramid, so it would make sense that the volume of a cone would be 1/3 times pi r squared, because the area of the base is a circle, so the area of the circle is pi r squared, and then times the height, where h is the height and r is the radius. All right, so let's find the volume of each of these figures. So for the first one here, we are going to need to find the height of our pyramid. And if I connect that height to half of my leg here, since the base is a square here, then half of that leg is 7 here. And then this was a 25, and this is a Pythagorean triple. So 7, 24, 25 is your Pythagorean triple. That means the height is 24. So the volume is 1/3 times the area of the base, since the base is a square, and that's 14 squared, times the height of our pyramid, which is 24. So 14 squared times 24 times a 1/3 gives me that the volume is 1,568 feet cubed. All right, looking at number 63, we are going to need to find the height of this triangle base. We have the height of the pyramid at 16. We just need the height of the triangular base to be able to find the area of the base. So drawing, or I guess we can do it this way, the height this way, and so that means that this is 5 here, and this is an equilateral triangle, so that means that this angle is 60 and this angle is 30. So we have the side across from the 30-degree angle. I need the side that's across from my 60-degree angle. And so I would end up multiplying the 5 by √3. That's the height of my triangle. So the volume is going to be 1/3 the area of my base, which is 1/2 the base of the triangle, which is 10, times the height of the triangle, which I just found to be 5√3, times the height of my pyramid, which is 16. So if I asked you for exact format, you would do a 16 times a 5 times a 10 to get an 800, and then a √3 in the numerator, all over a 3 times a 2 in the denominator, which is 6 centimeters cubed. This would be if I asked you for the exact, and actually that can be simplified even. It can be a 400/3. So let me actually simplify that before I put units. so a 400 root 3 over 3, which is approximately equal to, so if I asked you for the exact, you would leave it as 400 root 3 over 3. But if I asked you for a rounded version, you would then type that into your calculator to get a 230.94 centimeters cubed. All right, next one, I have a hexagon here. I need to know the apothem, and also I would need to know, well, I need to know the apothem to find the area of the base, but I also need to know the apothem to help me find the height of the pyramid. So what I'm going to need to do is I'm going to need to first, I'm going to take the hexagon out. We're going to work on the apothem real quick outside of the figure. So I am trying to find A. This is going to be 5 because it's half of this side, which is 10. And a hexagon, hopefully remember, has 120-degree angles. So the radius of your hexagon is going to split this into 60 and this into 30. So what this means is that using 30, 60, 90 rules, your apothem comes out to be a 5 root 3. So that helps me to be able to find the area of the base of this pyramid. But now I'm going to use that 5 root 3 and the 22 to help me find the height of my pyramid. And how I'm going to do that is I'm going to use the Pythagorean theorem. I have an h squared plus a 5 root 3 squared is equal to a 22 squared. So I have an h squared plus, and a 5 squared is a 25, and a root 3 squared is a 3. So a 25 times a 3 is a 75. And that equals a 22 squared, which is a 484. And so I have h squared is equal to, if I subtract 75 over, a 409. So now I'm going to take the square root of both sides. And so I get h is equal to, and a 409 isn't actually divisible by anything that I can think of evenly, so we're just going to round it to the nearest hundredth, so it's approximately equal to a 20.22. That's the height of your pyramid. So the volume is going to be equal to 1/3 the area of your base, which is going to be 1/2 times the apothem of 5 root 3 times the perimeter of your base, which there's 6 sides of 10, so that's 60, and then times the height of your pyramid. So I'm not going to put this in exact format because I already started to round. So a 20.22 times a 60 times a 5 root 3 times a 1/2 times a 1/3 comes out to approximately 1,751.10. And then there's no units, so I'm just going to put units cubed. Okay, so let's look at the next one, which is a cylinder. Not a cylinder, sorry, a cone. I apologize. So my radius of this cone is 2.5. So my volume is going to be 1/3 pi times 2.5 squared times the height, which is 8. So I get approximately equal to 2.5 squared times an 8 times a pi times a 1/3 gives me about a 52.36 inches cubed. All right, moving on to the next page. I have another cone. So 27 divided by a 2 gives me that the radius is 13.5. I need to find the height of this cone, so I'm going to do the Pythagorean theorem. An h squared plus a 13.5 squared is equal to a 22.5 squared. I do a 22.5 squared minus a 13.5 squared. I get h squared is equal to a 324. Taking the square root of both sides, I wind up with h is 18. So the height's 18. I have enough information now to move ahead with finding the volume. The volume is going to be 1/3 times pi times 13.5 squared times the height, which is 18. So 13.5 squared times an 18 times pi times a 1/3 comes out to be approximately 3,435.33 kilometers squared. Moving on to the next problem. I have a cone that has a volume of 1,309 centimeters cubed, and I have the height. I need to find the radius. So I'm going to set up my volume formula. My volume formula for a cone is pi r squared times my height. So what I'm going to do to solve for r is I'm going to divide by 8 first. So I have a 1,309 divided by an 8, which is a 163.625. I'm then going to divide by pi. So I wind up with about, oh, I'm sorry, I forgot the 1/3. Ooh. So actually, I'm not going to divide by pi right now. Let's do this. Okay. So 1/3 pi r squared. I'm going to multiply by 3 to get rid of that 1/3. And I wind up with 490.875 is equal to pi r squared. Now let's divide by that pi. I wind up with approximately 156.25 is equal to r squared. So to find r, I need to take the square root of both sides. I wind up with r being approximately equal to 12.5 centimeters. Okay, so the next one. Caitlin must build a sandcastle in the form of a square pyramid for a project. She bought 3 bags of sand, each containing 1,200 cubic inches of sand. And will she have enough to build the castle? So we need to find the volume of this pyramid. And so I have the height, I have the side lengths here. So I can easily find the volume by doing 1/3 times the area of the base, which would be 25 squared, times the height, which would be 18. So a 25 squared times an 18 times a 1/3 gives me that the volume of this pyramid is 3,750 inches cubed. Now she bought 3 bags of sand that contain 1,200. So if I do 3 times 1,200, that gives me 3,600 cubic inches of sand, which means she's not going to have enough sand. I'm going to have you try 69 on your own by pausing the video and then resume it to see the answer. All right, so you get about 2,052.6 0.61.